Welcome back. In this lesson, I'm going to talk about firewalls and also demonstrate so you can actually see firewalls in action. So once you've understood the network intrusion and you want to secure your local area network or your wide area network or network in general, you need to deploy and implement something called a firewall, and that basically secures your network. So firewalls are typically used to help protect a network from malicious attack and unwanted intrusion. And they're very common. Almost every network today has some kind of firewall. So it is just a barrier between your computer and the internet or external threats. So the security devices and zones, what you can do is you can, of course, create section zones and then deploy firewalls accordingly. So there may be multiple firewalls on your network. Security devices such as firewalls are the main defense for your company's network, whether they are LAN, wide area networks, intranets, or extranets. The perimeter networks help keep certain information open to specific users or to the public while keeping the rest of the organization's data secret. So here you can configure the firewall and tell your server or your network that only accept data from the trusted source or the allowed source. Packet filtering, what it does, it inspects each packet that passes through the firewall and accepts or rejects it based on the set of rules that you've configured. There are two types. Stateless packet inspection does not retain memory of packets, so typically the TCP/IP is stateless that have passed through the firewall. The stateful packet inspection, or the SPI, maintains context about active connections, so it keeps in its own cache or memory about the connections. The dynamic packet filtering is another name for this. Only packets that match a known active connection are allowed to pass a firewall. So it's a step above the stateless packet filtering. We can also have the network address translation filtering, also known as the NAT filtering. You can set this up on your router, for instance. And what this does, it filters traffic according to ports, TCP ports or UDP ports, which is user datagram protocol or the transmission control protocol. And this can be done in three ways. First, using the basic endpoint connections. Second is matching the incoming to the corresponding outbound IP address connections. And third is matching incoming traffic to the corresponding IP address and port. So this is yet another way to filter out and make sure you are deploying a certain type of firewall. The application level gateway supports address and port translation, and it checks whether the type of application traffic is allowed or not. If it is, it lets you through. And what this does, it adds another layer of security on top of securing your network by deploying a standard firewall. It is just an added layer, secure your applications as well. But beware that this type of deployment to secure your application is very resource intensive. The circuit level gateway is yet another way, and it works at the session layer of the OSI model when, for example, the TCP or a UDP connection is established. And what this does, it filters, inspects sessions rather than connections or packets. So it's not concerned about the data, it's actually concerned about the session itself. So once the connection, for example, has been made, packets can flow between the hosts without further checking. The circuit level gateways hide information about the private network, but they do not filter individual packets. So the main difference between the circuit level gateway versus your basic TCP/IP filtering is that it only is concerned with sessions. So we talked about firewalls, gave you a high-level overview of what that is. There are different kinds of firewalls you can deploy. For instance, every operating system has its own built-in firewall. Also, you can also purchase third-party firewalls. You can have a firewall on your hardware devices, such as your routers, for example. We also talked about packet filtering, the NAT filtering, application level gateway, and circuit level gateway. Next, let me in fact demonstrate. I'm running a Windows machine, so I'm going to show you the Windows firewall and how you can set rules and allow traffic from either going outbound or inbound. So from within my Windows apps, for example, I'm just going to go ahead and type firewall, for example, and it's going to bring up Windows firewall. So I'm going to go ahead and click on this. What this does, it opens up the Windows firewall page and allows me to set up various configurations and settings for the firewall as well. So what this does is simply helps prevent hackers or malicious software from gaining access to your computer through the internet or a network. So we have the private networks here and the general or guest or public networks, for example. And both of them are secured. If I click on the advanced settings, what I want to show you is the inbound and outbound rules that you can set. So if I go ahead and click on advanced settings, for example, brings up another dialog box, and here notice there are inbound rules and outbound rules. And I can configure each rule, and I can also configure policies, import policies and export policies. So it's pretty in-depth where you can configure as to what can come into your network and what can actually go out as well. You want to protect your network from both ends, inside as well as the external side. So I hope this helps. Practice with this, and let's move to the next lesson.